Assalamualaikum warahmatullahi wabarakatuh. We are from E05 and today we will be presenting our group assignment for MAT099. Before we proceed with the presentation, allow us to briefly introduce ourselves. My name is AZRA MADIHAH binti KAMARUL AZMI and I am the leader of the group.
My name is Mohamad ILHAM bin ABDULLAH.
My name is SYAHMI bin SUPIAN.
And my name is MOHAMAD ILHAM bin AZLI.
My name is PUTRI IZZATI binti JEFRI.
So, in this project, we explore how to use a first-order differential equation to analyze population decay in Georgia between 1989 and 2008. So, we apply the Malthusian growth model, which is expressed above. This model helps us estimate how population changes over time based on a constant rate of decay or growth, but we specifically look at the trend of population decline and calculate the population rate using this mathematical model. Finally, we use Simpson's rule to approximate the total area under the population over time graph, which helps us understand the overall population loss over the years.
Now, I will be presenting on the population trend of Georgia. The population data used in our graph was taken from the Worldometer, which is a reliable and updated source for demographic information. Based on the graph, from 1950 to 1988, Georgia's population steadily increased, reaching a peak of over 5 million people. However, starting at the end of 1980s, the population began to decline and continued to decrease throughout the 1990s and early 2000s. One of the key events during this time was in 1989, when a peaceful independence protest in Tbilisi, the capital city of Georgia, ended in tragedy. Soviet troops violently broke up the demonstration, causing many deaths and injuries. Because of this significant drop, we choose to focus on the year 1989 to 2008 for the deeper analysis. This 20-year period clearly shows a continuous decline in population with no sense of recovery. We selected the time frame to highlight the population decrease issue affected Georgia during those years.
Today I will be explaining about a particular solution. Before we find the particular solution, we need to find the general equation. Then we need to set the initial condition t equals to 0 to get A. After we get A, we need to set the t equals to 1 to find the decay constant, which is k. So from here, I can show you that a particular solution that I get is Pt equal to 5,046,271 exponential power negative 0.02417 t. Next, I will show you the graph of my particular solution. As you can see here, this is an exponential graph with the negative constant. So as you can see, the graph is declining. Therefore, the number of population is decreasing over time.
Now, let's proceed to calculate the future value and past value using the particular solution obtained earlier. To find the future value, we substitute t equals to 10 into the particular solution. For the past value, we substitute t equals to negative 5. By evaluating the particular solution at these specific values of t, we obtain the respective future and past values as shown in the calculations.
So now we move to discussion on how to calculate percentage error. Based on the calculation, the value obtained from particular solution have percentage error when comparing with actual value. So let me explain. First, what is percentage error? Percentage error is a way to measure how inaccurate a value is compared to the actual value. It tells you the size of the error in relation to the actual value, expressed as a percentage. For future value, we take 10 years after T0 and get the percentage error is 2.30%. For past value, we take 5 years before T0 and get the percentage error is 3.42%.
The actual value of the number of people in Georgia decreases, but not in the same manner as the particular solution. The particular solution depends on parameters such as initial population and growth rates. If these are estimated incorrectly or become outdated, the solution will no longer match the actual value.
The population of Georgia is decreasing due to several reasons, like immigration of the locals to seek for better economy, and this trend has been fueled by the high unemployment and limited domestic opportunities. Besides that, political instability and conflict starts in early 90s caused the country face a lot of significant displacement and immigration. The low birth rates also becomes one of the factors of decreasing the population in the country. However, in the future, Georgia's population is expected to grow steadily with the urban areas leading the expansion and demographic shifts, presenting both opportunities and challenges for the state's future.
So, in conclusion, through this project, we successfully understood how to apply first-order differential equations in a real-world context. We determined the decay in Georgia's population from 1989 to 2008 using the Malthusian model and were able to identify key factors behind the drastic decline. So, we also calculated the percentage error between actual and estimated data and explored reasons for any differences. Overall, this analysis helped us recognize the practical importance of mathematical modeling in understanding population trends.
So for task 2, we were given the task to estimate the area bounded by the curve given function -5x cubed, ln sin x squared, the axis of x equal to 0.2 and x equal to 1.2, using Simpson rule with 6 and 10 subinterval. Simpson rule is a numerical method used to approximate the definite integral of a function. Basically, it estimates the area under a curve. More specifically, it's used when you can't integrate a function analytically. It's based on approximating section of the curve with parabola rather than straight lines.
Let's calculate for the 6th subinterval. First, we need to calculate the width, denoted as h using the formula h equal to open bracket b minus a close bracket over n. We substitute the values of a, b and n, which is the number of subintervals, into the formula, and we get the value of h equal to 0.1667. As shown in the Excel sheet, the values of a, b and n are entered in the cell D4, H4 and I4 respectively. The formula to calculate h is typed in cell G7 as equal sign, open bracket, H4 minus G4 close bracket over I4. This will automatically calculate the value of h in Excel. Next, to generate the x values, we start with a as the first x. To get the following x values, we keep adding h to the previous x. And we continue this process until we reach the limit, which is b equal to 1.2.
Now, we will be finding the value of fx. To find the value of fx, we need to insert the value of x into this equation. Then, we need to assign the coefficient accordingly. For the first and the last term, the coefficient should be 1. Meanwhile, for the odd term, the coefficient should be 2. And the even term, the coefficient should be 4. Then, we will be multiplying the coefficient with the fx. After that, we need to count for the total, which is the sum of all the coefficient that we have multiplied with fx. Then, we will be finding the area by using this formula. Next, I will show you the graph with the 6 subinterval. So as you can see, this is the graph, and the area that we got is 0.815.
Moving on to find the area using 10 subintervals. Calculate the width using the formula h equals to b minus a over n and replace the n equals to 6 before with 10. And repeat all the same steps as finding the area using 6 intervals. Calculate the total and find the area under the curve. This shows the graph obtained after dividing the limit into 10 intervals. The area we calculated is 0.81451.